Okay, great. So our next talk is about modeling incorrect programs in the real world with Dafny. So we'll just wait 1 second while the presenter is getting hooked up.
The usual. Sorry.
Great. Yeah. So here we have James, and I'll give it over to you.
Yeah, the usual advice is never to start with an apology, but I'm going to ignore the usual advice because it seems that every single other talk in this entire incorrectness workshop is about, well, incorrectness logic or variants of it, and that's not really what I'm talking about. Although I think it's related, and I'm pleased to have the opportunity to talk about it because hopefully people will be able to tell me A, what I'm doing wrong, and also B, how it is in fact related to other work on incorrectness. This is stuff that I've been doing with a bunch of people. Tobias is on there, particularly Sophia and Julie Mackay for a while now. At least 5 years ago, there was this obscure talk about swapsies on the internet. And effectively what these things are trying to do is look at how we can specify and then reason about partial programs or programs in what we call the open world. And what we mean there is, well, this kind of thing. This actually happened to me this morning. That's my phone busily saying, you know, should I actually trust the computer that I'm plugged into? Should we trust computers? I'm very tempted to mention the police and, the Police and Crime Evidence Act, 1984. We'll get there. Which, of course, requires legally in this country that you have to trust the computer. The computer is your friend. The computer is correct by presumption, by legal presumption under the common law. This is why there was a statement by the British Computer Society last week suggesting that that's probably something that could change, and why I'm taking a couple of minutes out of my talk to randomly talk about other stuff, which is, I think, if you happen to be engaged in formal methods or formal specification work, and I don't know why, I trusted the computer. Now may in fact be an extremely good time to talk to the next government about the kind of legal standards and about the kind of academic research that would support, well, you know, trying to avoid national scandals involving lots of people killing themselves. Right, anyway, so, as Ward Cunningham used to say, I am the bank account. What do we mean by this open world stuff? Well, the environment we're working in, we'll say an open world, you could think about it as JavaScript. You could think about it as pretty much any situation where the code that we write has to connect to programs that come from somebody else whom, well, we don't really trust. Perhaps they're the post office, perhaps it's somebody else, who knows. So the system as a whole contains of both our code and then third-party code. Perhaps we're interested in future modifications. So in some sense, the third party might be ourselves projected into the future, as odd as that may seem. We may have invariants or requirements for our design that are necessary, say, to maintain security, and what we're saying is we don't want future modifications to the system to breach those requirements, or at least not to breach them without knowing what the hell is actually going on. So this is where we will often talk about things like trust, which I guess pretty much in the sense, do you trust what the post office computer is telling you? Are you willing your phone to trust the laptop it's plugged into? And something that I won't talk about in this talk, but is kind of lurking in the background, which is the risk, which is the idea that when something is incorrect, and this I guess is one of the connections back to incorrectness logic, maybe, if something is incorrect and we go ahead and run it anyway, and this is why I'm going to be spending, unfortunately, the afternoon in the parallel workshop on object capabilities, can we quantify the damage that will happen? If we run some incorrect code, or we run code that we're not sure whether it's correct, what I'm going to be talking about in the rest of this talk is about how we can make our specifications in some sense, if not robust to those conditions, but at least aware of them, And then there's like this complementary area of work, which again, we're carrying on with, haven't got completely tied up yet, about what happens in the worst case, if in fact we trust something we perhaps shouldn't have trusted, how much we're going to lose. So again, comparing this stream of work, we could call it robustness, call it various things. Then again, the traditional spec is a closed world. We will assume that we have the entire program and that we can verify the entire program. Things like Bertrand-Meyer, I know I shouldn't mention that associated with Popple, designed by contract, where he says when you're writing code you never check your preconditions. That is an embodiment, that rule is a hard embodiment of this notion of a closed world. Because you can only not check your preconditions if your preconditions aren't part of the attack surface. If some kind of adversary code cannot get into the middle of your program and then call something, and if you're assuming you're only being called by people you trust, well, then if you are called by somebody who is untrustworthy and you don't check that the preconditions, you probably won't be able to maintain whatever guarantees you need. So the open world has larger attack surfaces. Whereas the traditional specifications are pre and post conditions. Typically, we will have pre and post condition specifications, but we will also add in temporal conditions. And again, there's a couple of papers at Uppsala and Phase, I think, over the last couple of years where we've been working on these ideas. Again, I think it's related to this distinction between sufficient conditions. If I've got some kind of horologic specification which says you may run the login method if you have a username and a password for the system, we might be interested in a necessary condition which would say you only can log into the system if you possess a valid username and a password for that system. Okay? Now I won't wave the laptop around because it's plugged into the projector, but the laptops you have, all of those will meet that sufficient condition. If you type your username or whatever, or give it a fingerprint, you can log in. But in fact, they will generally not meet that necessary condition that you have to have a username and a password to be able to log in. And is this actually because of a bug? Peter's grinning. The answer is no, because there's a .rhosts file, which pretty much says I'm willing to trust these other computers, and if I've got a valid login on that computer, I want my computer to accept it as a valid login for my system. And that perhaps is an example, again, of where you could say, if we had written this somehow had written this necessary condition down, saying, look, we really want these people to have a username and a password for this damn thing to log in, then presumably in some future world that Sophia and I and people in this room and everyone else are building, we want to get to the point where if you tried to add in SSH with that hole in it, it would actually come back and say, I'm sorry, you put this in, you have broken this systemic, non-functional, whatever word you want to use, holistic, necessary condition that you have to be able to do that. Often what we'll find is that whereas traditional specifications really make individual functions explicit, often what we hear is we're going to make the emergent behavior explicit. That is, what the system as a whole does rather than just the particular individual functions, whereas existing specifications, that emergent behavior is implicit. If you've got either all the code or you've got specifications of all the code, you can work with them to derive perhaps the necessary conditions. Well, you can work with them to derive the necessary conditions, but they are not made explicit. We'll make them explicit. And in this talk, the kind of condition or emergent condition I'm going to be talking about is this notion of trust. You know, would you trust this computer? Would you trust this computer? Which is unfortunately, Imperial Computers Limited, anybody? You heard of them? You know why you haven't heard of them? Because in the late 1990s they fucked up a government contract called Horizon and then renamed themselves as Fujitsu. Do you watch television? Oh God, you're all millennials. You don't watch television, do you? Look, you should. I don't want to say this because it's probably not true, but doing something equivalent in New Zealand a few years ago did work for me. Watch the ITV program on the Post Office. I mean, you should do that as in your professional responsibility as a software engineer anyway, but I can bet that there will be grants that will be funded that will say, oh, remember the Post Office thing? We're going to try and do something to stop that happening again. So anyway, I'm using this picture because if you go to Fujitsu.com today, you can still get a sales brochure for the Horizon system, of which this is part. And, again, the reason I'm using this is not just the whole Horizon thing. In fact, this isn't part of the main Horizon problems aren't what I'm really talking about. But just to make the point that if that's the center of Horizon, there are other systems, particularly other banking systems in here, with which it has to interoperate. These things are third-party systems, and the question for the rest of my talk is basically how do you make those dependencies explicit in your specifications? So, some worrying many years ago, before the pandemic, Sophia and I came up with specifications that look like this. Don't ask me to explain that because Sophia wrote it and I just copied and pasted it into the slide. Plus the paper was repeatedly rejected because we sent it to Popple. No, in fact it was rejected from all sorts of places. If you want to know about being rejected from Popple, I do strongly recommend the panel at last year's Popple that is available on YouTube, where many esteemed panelists go through and explain their favorite papers that they know were rejected from Popple and why it was the right thing for such significant papers to be rejected. Anyway, sorry, I really shouldn't do this. They're never going to invite me to keynote, are they? Okay. So, the point about this is part of the specification. And this is actually the reason why it got rejected, because in the version that we've done so far, there is a circularity here, because what this is saying is in the specification we want to have, a base level construct that says, does this object obey that specification? Now, this looks pretty much like, does this object have this particular type? And in a system where you did have a bunch of behavioral types where everything was explicit, that's kind of what it could be. But then if you think about what it means to be an open system, that's really what you can't have. Because if all the types and all the behaviors and all the types of your systems are all completely guaranteed, then from our perspective we say you've got a closed system because you've trusted everything, you've checked everything. That's all fine. That's great. If you're in that world, that's fine. If you're not in that world, and I'll resist making the political analogies even more explicit, then you have this question about how can you reason with that, and when I put that slide up, basically what this says is when it comes down to it, we have sort of a classical, or we had a classical Hoare logic, and again, the latest versions of this are in a paper that came to, I guess it's the year before last now, and we basically started encoding everything into Coq, and then haven't yet got anywhere near the point where we can really tackle this problem of trust and risk, which is where the brief bit that I am doing, or have been doing, I'll talk about, which is the guy with the best hair in the business, Ruston. He's got a logo for Dafny, but every time I see this guy, I think, that's Dafny, isn't it? Really, it's Dafny, it's Ruston. It's like you're having a conversation with them. So, how many people, I don't know, if you don't know Dafny, that's fine. You should spend your time on Coq anyway, because you won't get papers into Popple if you really just work in Dafny. You've got to do the Coq. Even Lean is probably a bit, I don't know, sorry. Look, I come from the world of Uppsala and things, right. So basically this is a simple box interface which is effectively a reification of a variable, and the interesting thing there is that we're taking in integers, but then we effectively have a constraint which says if you call set, trying to set it to something less than 0 or less than equal to 0, then we won't actually do the assignment. That is how you write an abstract specification in Dafny, write it as a trait, and then, oh yeah, that's right, important thing, well, a semi-important thing here, in which Dafny is sort of veering off towards the dependently typed languages, and there was a great paper by Jan Hughes and some other guy at the workshop on Sunday? Yeah. Sunday, which is trying to start pulling out those differences. Dafny has these things called ghost predicates, which you can think of as graded monads with a grade of 0, meaning these things are usable in the proof, but they are not usable in the actual running code that you might want to generate and run. Okay? Ghost variables. It's fairly standard. For those of you who speak only Agda, that's what it means. So, in this case, there's a ghost predicate, and Matthew Parkinson is probably in the other room, otherwise I'd apologize for the fact that, well, in fact, that's a class invariant. And you know, what's the line? If class invariants had reached the end of the road, it would be necessary to reinvent them. Sorry. Right. So we have a class invariant that basically says, look, the value is greater than 0, and it's morning, it's evening, and we can do an implementation, which is not, you know, that's just the Dafny implementation of it. Okay, so far so good. What I've been playing around with is effectively doing this, which is a transformation of that, where, as well as that ghost predicate for the class invariant, I've got another ghost predicate, which I call a Bayes. And the idea is this is a ground level analog of that meta-theoretic Bayes that I had in the version of the specification language 5 years ago. It's rather ugly, but you know, it actually kind of is in Dafny. And the point here, it's an opaque ghost predicate. The ghost predicate means this only applies in specifications. You cannot test this at runtime, because if you could, that would be the analog of saying, well, I can actually go and ask, because basically a Bayes is whether this thing is trustworthy or not. By making it ghost, I can't actually go and ask that at runtime. And by making it opaque, that then means that Dafny will not look at the definition. So in as much in Dafny as I write code to this interface, and the other thing, the transformation I've done here basically is all of the pre and post conditions are conditional on a Bayes. So what this means is the code gets somewhat nastier, and I can write code like that, and this is basically exactly the same code as I had before, and the pre and post conditions just all have this Bayes in there, and up there there's a ghost predicate, and we bind that to actual true. I think actually we may have had to reveal it in the latest version of Dafny, but this lets you write, in this case, something that behaves the specification. It's an evening, it's morning, it's a new day. What we can also do is write stuff like this, which the important thing here is down here. That's really the only significant difference, which says we always do the assignment. We always do the assignment, okay? Now this verifies against that trait specification. How? Well, because every specification here is now dependent on this Bayes predicate, and in this bad version, the Bayes predicate is false. Would you ever want to write code like this? Well, the answer is no. Well, only to demonstrate at workshops. But the point is, this is effectively widening the standard interface to allow us to have both good and bad versions of the code, depending on whether or not these things are Bayes. And then, we can write code like there, where effectively, okay, we're making a good box, we're making an evil box, we're sending it to the same code. And down here we say, well, if the box obeys, then the box should be valid. And then we can call methods on it. And if we want to say this thing is going to have a value of 100, which is what it should have because of the specification, because when I wrote that trait specification, I said if you handed a negative number, it ignores the assignment. You can write this and it will verify. But if you just say, look, this thing has the value of 100, it won't. It should all be kind of straightforward, but I think it's quite useful. And the important point here is that here we are effectively starting to accumulate explicitly the dependencies on the things that we don't trust. So that's basically it. There's a bunch of other stuff here, some of which I have done, some of which we are still working on. There are all kinds of interesting problems that we'll have to deal with. Yeah. And I've got a bit of time for questions for a change.
do we have any questions?
Yeah, I'll take abuse or pointers to papers published in, 2011 that I should have read. Yeah.
Hi, thanks for your... It's on? Okay, very well. Thanks for the talk. I was wondering a bit about why you're doing this with the obeys clause. Is the point that you want to show that if a client or this outside world code is well behaved, then your code will get the proper result? But if it's evil, like you said, then you get an okay error? Is that a point?
Yes and no. So that's kind of half the point. So half the point is, if things go okay, it will go okay. But where we can get ourselves, as we've seen even in that simple example, we can have code that generates wrong results. What this puts in is it puts in that assumption. When in the earlier version it would have actually been the obeys clause in the specification language, and here the only thing we can prove is this, right? And this bit here is recording the fact that we are actually dependent on this external thing that we don't control. If we want to get rid of it, well, we could actually access the value, and then we can test it, and then we can test it dynamically. Dafny actually has features built in for doing that now, and there's work by Jonathan Aldrich and others on gradual verification, which is kind of also touching on this work, but I'm saying, look, that's in terms of sort of a methodology about how you might go about developing things. I'm saying, look, there are actual times when you just want to keep track of this information. If you do a lot of this, and if there are a lot of those systems, you will get a whole lot of these obeys clauses hanging around as preconditions, effectively tracking the assumptions underneath your specification. That's horrible, but at least it's in your face. And you've got the option of writing code that actually does a dynamic check if you decide you don't want to trust these things for some reason. So, but yeah, I mean, there's I think there are various examples, and typically it turns out that this is quite nice for cases where if both parties in a transaction are trustworthy, it'll all go through. If one party is trustworthy and one party isn't, depending on the implementation, you can often detect that, and then the thing won't go through. But if both participants are lying through their teeth, I'm tempted to say this is, of course, the anarcho-syndicalist assumption underlying most of the work on bitcoins and other digital currencies, but I wasn't going to make those kind of political comments. In fact, then you can't actually really give any guarantees. Because you end up with, well, the guy on the left obeys, if the guy on the left obeys this and the guy on the right obeys this, then the right things will happen, and if not, who knows what will happen? Because basically you get the situation where each participant in the interaction is just having to carry on whether or not it makes any sense on the off chance that they'll be given something of value. So, yeah.
Thanks.
Okay, we can do one more quick question if someone has.
You might have a quick question, but whether you get a quick answer or not is
That's true.
I'm happy to unplug my laptop.
All right, let's take the speaker again.
Okay.